Alright, section 1.3 deals with algebraic expressions and performing operations with those expressions. First off here, if we have this addition sign and these two algebraic expressions when we're going to add, you would add like terms. So the x squared and the 4x squared, which would turn into 5x squared. And then the 3x and a negative 5x would become negative 2x. And a positive 2 and a positive 3 would be a plus 5. So our answer to that would be 5x squared minus 2x plus 5. Then if we turn this into a subtraction problem, now we have x squared minus 4x squared, which would make a negative 3x squared. Then we'd 3x minus a negative 5x, which would be the same as plus 5x, which turns into plus 2x. No, that doesn't, because it was a positive 3 first, so therefore that is going to be 3x plus 5x, which makes 8x. And then we have 2 minus 3, which becomes a negative 1. And that would be adding those two algebraic, or subtracting those two algebraic expressions. The other types of things that you'll end up having to do would be to multiply some things together. And when you multiply, you have to use the distributive property. And so first you have to multiply x by each one of the terms in the other part, the other expression. And so x times x squared is x cubed. X times 3x squared is a plus 3x squared. Actually, it was x times 3x. And then x times a negative 6 is a negative 6x. And secondly, you would distribute the 2 to each of those. And 2 times x is 2x squared. 2 times 3 is a positive 6x. And 2 times a negative 6 is a negative 12. And so then you can combine the like things. Nothing combines with x cubed, so it just stays as x cubed. 3 and 2 makes 5x squared. Then these two are 0 and then minus 12. And that is what you would do for multiplying two algebraic expressions. Now some other things that you're going to end up having to do in this section would be to factor things. Here, this first one, x squared plus 8x plus 12. Remember, when you're factoring, you need to find pairs of factors of 12 that will add up to 8. Now, just to go through and list all the pairs of factors of 12, that would be 1 and 12 and negative 1, negative 12, 2 and 6, negative 2, negative 6, 3 and 4, negative 3, negative 4. Now, I don't expect you to have to go and list all of those to figure out the pair that gets you to 8. You should just be able to come up with the pair that gets you to 8. And so in this case, it would be the 2 and the 6 that are both positive. So your answer would become x plus 2 and x plus 6. And then with this one here, same thing, except now we have a negative 40 that we have to get. So now we have a positive and a negative. So positive 1, negative 40, or you can switch them, 2 and positive 2, negative 20, or they can be switched. Positive 4, negative 10, positive 5, negative 8. And like I said, you can switch all of those. And none of these get you to a negative 3 except for that one. And so that would be the correct choice. Now, had you listed a negative 5 and a positive 8, well, that's a positive 3, which is the opposite, which just means the negative sign has to be switched from one integer to the next. And so, because those are the two factors, you would have x plus 5 and x minus 8. Now, some special types of factoring that you're going to need to remember about would be the difference of squares In this case, it's a squared minus b squared. It has to have only two terms. Both terms have to be perfect squares. It has to have subtraction between the two, and if that is the case, you figure out what the square root of each one of the terms would be, and you take one factor as the subtraction of those two terms. The other one is the addition of those two terms. And so for our examples here, x squared minus 64, since it's subtraction and those are both perfect squares, the square root of x squared is x. The square root of 64 is 8. So you can have one that's x plus 8, and the other is x minus 8. Even looking at this next example, this is a perfect square. The square root of that is x plus 2. The square root of this is 5. So you would have x plus 2 plus 5, and then x plus 2 minus 5. And now simplifying that down, this turns into x plus 7, and this one turns into x minus 3. That's the difference of squares. It has to be subtraction between them, and both the first and the second term have to be perfect squares in order for you to factor it that way. Then there's the sum or difference of cubes, which is similar to the difference of squares, except for it can be either addition or subtraction. If it is addition in between, then your factors become the square or the cube root of a plus the cube root of b, which are just going to be a and b, and then you multiply by a squared minus ab, not the 2. That's for something else. And then plus b squared. If it is a subtraction in between the two, then your factors become a minus b and a squared plus a times b plus b squared. Take the cube root of both of those two things, and they go first. Use the same sign in your first binomial factor, and then take the first term and square it. Multiply the two terms together. Take the second term and square it. And with this, the first and third terms are always plus. The middle term is the opposite of what the sign as what the binomial is, and the binomial has the same sign as what was in the original problem. And so looking at these two examples, or this example here that we have, it's 64x to the 9th minus y to the 6th. Well, the cube root of 64x to the 9th is going to be 4x to the 3rd. Because for the exponent, you just divide 9 by 3. You have to figure out what the cube root of 64 is. And the cube root of y to the 6th would be y squared, because you're just dividing by 3. And so your factors become a minus b times a squared plus a times b plus y squared. And so there is the factoring of perfect cubes that are either the sum or the difference. So now the thing that would happen if this turned into a plus sign here and you had to factor it, nothing would change here except for that would turn to a plus and that would turn to a minus. Now then, the last thing you're going to end up having to do is simplify some things like these. So first off, that has to be used as the denominator under both of these two things. So 8x to the fourth y cubed over 4x squared y squared plus 20x squared y to the seventh over 4x squared y squared. And so now we can simplify just this part. 8 and 4 would make 1 and 2. There's 2x's here which can go away, and we can take that down to a 2. There's 2y's here which can go away, and that goes down to a 1. So now we have nothing left in our denominator, so it is going to be 2x squared y plus, here 20 and 4 goes in, so that would be 1 and 5, and those are the same, so they go away, and then 2y's go away, which leaves you with 5 in the numerator, and so now we would have 5y to the fifth. Now then you can factor out, since this has a y and that has a y, you could factor that out to get 2x squared plus y to the fourth. Either way would be fine for simplifying that as much as you can. Then looking at this one, same thing. First we can factor out an 8 out of both of those two things. They also have an x in common, so we can take an x, and that's a 5 and that's a 3, so x cubed because it's the smallest exponent. And then with the y's, which are both in the same, you take the smaller exponent, and it's y squared. And so now when you divide these two things together, 16 divided by 8 is 2. X to the fifth divided by x to the third is x squared. And the y squareds go away. And then you have plus. And now we do the same thing with this term and that one. And so 8 goes into 8, so x cubed goes into x cubed, and y squared goes into y cubed with a y left over. And then that would be your final answer, 8x to the third y squared, and 2x squared plus y. And that concludes the lesson for section 1.3. You can use the rest of your time if you have it today. Tomorrow will be our day of questions and giving you a little more work time if you need that.